Greetings, dear friends. Happy to be here. Before summarizing all the processes, I'd like to share with you one more important piece of information. Without this information, the picture of the ongoing processes on Earth as it enters the 12,000-year cycle of catastrophes will be incomplete. As you already know, there is an exponential increase in the number of a mysterious phenomenon on Earth, deep focus earthquakes. The mystery of these earthquakes lies in the fact that they are recorded beneath the Earth's crust, not within it. To understand the oddity of this phenomenon, let's recall the structure of the Earth. The Earth has three main components: the core, mantle, and crust. The mantle is very hot and viscous. You can say it's pliant, like clay or a slime. There are molten streams of this substance in the mantle, called liquid magma. The Earth's crust is a thin, brittle layer on the surface. It can be compared to a cracker. It breaks. That's how ordinary earthquakes occur in the Earth's crust. But deep focus earthquakes occur beneath the Earth's crust, within the mantle, which is pliant like a slime. There's nothing there that could break. Deep focus earthquakes can be called intramantle explosions. Since 1995, an exponential increase in the number of these earthquakes has been recorded. As you may remember, a number of sudden changes in the Earth's geophysical parameters were also recorded in 1995. The most powerful deep focus earthquakes occur at great depths, 500 to 600 kilometers, precisely where we currently observe the greatest temperature contrast in magma flows. Look at the graph. These depths are highlighted by the red rectangle. Intramantle explosions have also begun to occur at depths ranging from 75 to 200 kilometers, although they are currently not so powerful yet. You can see on the graph how these earthquakes have been increasing in depth. The increase in earthquakes at depths of 50 to 100 kilometers in the upper mantle layer indicates that magma is now rising close to the Earth's crust, whereas there are almost no explosions below 800 kilometers because the mantle substance at these depths is almost completely melted by magma. Explosions at depths up to 800 kilometers are extremely powerful. One such explosion is much stronger than the entire nuclear arsenal of humanity. We have no weapons comparable in power to these intramantle explosions. Now imagine what would happen if these explosions reached the depths of the Earth's crust. One such explosion could wipe an entire country off the face of the Earth. Why did this abnormal phenomenon, deep focus earthquakes, start occurring since 1995? This is a dark spot in science because as of now, the majority of scientists don't even comprehend the threat posed by deep focus earthquakes. The danger of deep focus earthquakes is significantly underestimated by modern geologists who fundamentally misinterpret the processes occurring in the Earth's crust. This misconception leads them to overlook the fact that our planet is rapidly approaching a catastrophe. This misconception allows present-day geologists to turn a blind eye to the increasing number of deep focus earthquakes. Their error stems from the assumption that our Earth hasn't changed in size for billions of years, and that the Earth's features are solely determined by the tectonics of the lithospheric plates. You are about to learn one of the greatest secrets of geology, unknown to the majority of the world's geologists today. However, if this remains a secret, it will have devastating consequences for the life of each of us. For you to understand this, allow me to briefly describe the modern theory of the Earth's crust structure. According to the principles of plate tectonics, the lithosphere is divided into several plates that move across the mantle. Continental plates are thicker, while oceanic plates are thinner. In the ocean, the plates move apart as a result of mantle substance intrusion, where new oceanic crust is formed. This process is known as spreading. The Mid-Atlantic Ridge is considered a prime example of spreading. It is believed that along the margins of the Pacific and Indian Oceans, the edges of oceanic plates subduct beneath the thicker continental crust. Moreover, it is believed that the plate is sinking under its own weight. This imagined process of one plate sliding beneath another is called subduction. In fact, this is just a theory, while in reality things are quite different. The theory of subduction zones emerged because deep focus earthquakes began to be registered exactly in these regions. And since science posits that earthquakes can occur only in the brittle plates, scientists concluded that the crust extends so deep into the mantle. However, this idea is incorrect. The fact is that the oceanic crust doesn't subduct under anything. It is simply impossible. Therefore, the cause of deep focus earthquakes is completely different. And now you will see this for yourself. The modern theory of subduction zones fails to answer the following simple questions. Question 1. How can an oceanic plate with a density ranging from 2.8 to 3.2 grams per cubic centimeters sink deep into the mantle, the density of which ranges from 3.6 to 4.6 grams per cubic centimeters? In other words, the density of the mantle, even in its upper layers, is almost twice as high as the density of the crust. Therefore, plates cannot sink into the mantle under their own weight, even to shallow depth. This is impossible due to the laws of physics, and it's all the more impossible because the rocks inside the mantle are under enormous pressure that increases with depths. It's like trying to push a cracker into a piece of thick rubber, like a tire. How can a plate go into the mantle like a knife into butter without experiencing any resistance from it? This is absolutely impossible. Question 2. The speed of plate's movement ranges from approximately 2 to 12 centimeters per year, and the temperature in the upper mantle averages 1,200 degrees Celsius. Attention! How can the plate at such a slow speed not melt inside the mantle over such a long period, and not shatter into small pieces under such pressure? Because their theory suggests that the plates sink to a depth of 700 kilometers, which would take hundreds of millions of years. Question 3. The plates are believed to subduct into the mantle at angles between 30 degrees and 90 degrees. I mean, according to this theory, the plate would be bent at these angles. However, a plate cannot withstand even minor bending without deformation. Look, the entire ocean floor is covered with fractures, indicating the brittleness of the plate. Therefore, during subduction, series of cracks tens of kilometers wide should have appeared. Where are they? These cracks have not been found in the subduction zone areas. Question 4. Every layer inside the Earth is moving. There is plate motion, mantle motion, and core motion. The core in particular rotates faster than all other layers of the Earth. There is a regularity. The farther a layer is from the core, the slower its movement speed. As you already know, plates move at a rate of 2 to 12 centimeters per year. The mantle, which is closer to the core, moves faster than the Earth's crust. This means that any end of the plate, for whatever reason submerged into the mantle, would be torn off by the mantle's flow. But it doesn't break off, because it's just not there. Question 5. The lengths of mid-ocean ridges where the crust is accreted significantly exceeds the lengths of subduction zones, where excess plate material supposedly crawls in. So what does this imply? More crust accretes than crawls into the subduction zones? There are many more similar inconsistencies and unanswered questions. Moreover, 60 years ago, scientists perfectly understood that the subduction theory and lithospheric plate tectonics in general were entirely untenable. Thousands of scientists from various countries wrote about this, relying on the empirical experience of geologists and geophysicists from all over the world. Nevertheless, the erroneous theory was imposed and artificially propagated as the dominant theory. Similarly, faulty theories regarding climate change are being imposed now. Do you wonder where that extra part of the plate which doesn't subduct and has never subducted into the mantle actually goes? Nowhere. The Earth is expanding in volume, and while it used to expand slowly, now it's happening rapidly. That's right. Imagine our Earth was once as small as Mars, but over hundreds of millions of years it grew to its present size. There are numerous works by eminent scientists based on a vast amount of scientific evidence that support this. But we will talk about this next time, if we have an opportunity. Now, let's go back to deep focus earthquakes. What's actually happening there? At the boundary of the continental and oceanic plates, their vibrations are more intense than in the middle of the plate. This is why earthquakes occur at the plate boundaries. During an earthquake, energy is released. Some of it propagates through the plate itself, some of it goes into the atmosphere, and some goes into the mantle. Although it's a small force, constant jolts deform the mantle, heat it up, and liquefy it. So the more regular earthquakes we observe in the Earth's crust, the more favorable conditions are created in these areas for the formation of deep focus earthquakes. Seismotopography reveals the differences in the movement of acoustic velocities at the boundary between the hotter liquid and the colder viscous mantle, as well as deep focus earthquakes caused by the collision of slightly cooler and hotter magma streams. The thermal contrast occurs primarily because hot magma, superheated by the core, is currently rising from the Earth's interior. Today, as Earth enters the cycle of external cosmic influence, additional energy is reaching the Earth's core, which turns into heat and warms the mantle. But the problem is that now, unlike in previous cycles, this energy is not dissipated from the mantle as it should. This is happening because the ocean has stopped performing its cooling function. It can be compared to an overheated nuclear reactor when its cooling unit breaks down. The temperature of the mantle magma has been stable for billions of years. If the magma temperature drops even by a degree or a degree and a half, especially in the lower layers, the mantle will start solidifying. However, the magma temperature has begun to rise now. As a result, the mantle, which in previous cycles had only been slightly melting from heating of the core, started melting with a record speed in this cycle. Magma near the core has become extremely hot and fluid, rapidly eroding the mantle and creating new paths within it, like holes in cheese. As a result, ducts begin to form in the mantle itself in zones of increased melting. They're like caves in the mountains that are eroded by underground rivers winding inside the mountains. The shape of the caves is determined by how well the rocks inside the mountain dissolve. Similarly, magma dissolves the mantle unevenly due to the difference in its malleability of the substances. As a result, new magma streams started to develop in certain parts of the mantle. And because the magma temperature and consequently the mantle temperature is increasing, the magma becomes more fluid and the number of magma streams increases rapidly. Due to the sudden acceleration of the Earth's rotation in 1995, the centrifugal forces began to push red-hot liquid magma from the core towards the crust. As a result, this magma began to rapidly ascend through the new magma channels. Magma at great depth is pressurized by the layers of the Earth's crust and can be compared to a compressed spring. When magma rapidly melts its way up and ascends, it expands in volume because there is less pressure on it from the rocks as it moves higher. This means that magma can straighten out like a spring, thus dramatically increasing in volume. This rise and expansion of magma occurs abruptly, so the movement of hot magma occurs at high speeds. When the hot magma ascends higher, it meets a stream of colder magma, because the closer to the crust, the colder it becomes. The temperature difference between them can be just a few degrees, but it is enough to form magma flows of different temperatures heading towards each other. Some new magmatic rivers approach directly under the very plate. This is what we observe in Siberia. After magmatic rivers transfer their heat to the plates, they cool down and descend. And when the descending river of magma meets the ascending red-hot river coming from the core, their collision leads to what we call cavitation explosions. These powerful cavitation explosions release gases. The cause of the explosion is actual nuclear reactions that release enormous amounts of energy. It would be more accurate to call it an intramantle nuclear explosion. However, we call these explosions in the mantle cavitation explosions only because of the associative similarity. It is these explosions that are being registered as deep focus earthquakes. The greater the contrast in temperature, velocity, and pressure between the colliding magma rivers, the greater the explosion. In terms of power, these explosions are equal to millions and billions of nuclear bombs, and they have never occurred in the mantle in such quantities before. Take a look at the map showing the frequency and number of deep focus earthquakes in recent decades. Currently, deep focus earthquakes are also being detected outside the plate's boundaries, and scientists have no idea how to explain this. Look at the map with the examples of the earthquakes outside the plate's boundary zone. However, they also occur in other parts of the mantle. It's just that the shock wave is not always detected and correctly identified by the sensors. The shock wave propagates tangentially from each of the explosions. It is possible to determine the direction of the intramantle explosion by drawing a straight line from the epicenter of the deep focus earthquake to the center of the Earth's mass. The explosion occurred precisely along the line from the epicenter of the Earth's center of mass, the core, at the depths detected by the sensors. An intramantle nuclear explosion affects both the Earth's crust and the Earth's core. This is similar to the Yudkin effect, when shock waves from explosions within the mantle destabilize the Earth's core even more. These explosions cause further melting of the mantle in the Earth's interior, which generates even more heat and pressure. As a result, the amount of red-hot fluid magma increases even more, and the temperature inside our planet rises even higher. Each intramantle explosion increases the amount of heat. Since real nuclear reactions with a power of billions of nuclear bombs are occurring in it, the temperature at the epicenter of the explosion reaches many millions of degrees. Because of this, both the magma and the mantle melt even more and the temperature rises even more. This happens with every deep focus intramantle nuclear explosion. The explosions also change the direction of the magma rivers themselves. They collide, causing more and more such explosions. This leads to an exponential growth of explosions. There are not so many of these explosions under the surface yet, because the difference in the temperature and pressure of the colliding rivers is not great, and so the power of explosions is less. External cosmic influence heats up the core and increases entropy. Moreover, the intramantle explosions release more heat. Add to this a malfunctioning cooling system, meaning the ocean, which has stopped dissipating heat. The intramantle nuclear explosions cause self-acceleration similar to the process of bacterial division, and therefore their number is growing exponentially. Explosions within the mantle also increase the load on the Earth's crust, which in turn leads to an increase in the frequency and power of earthquakes in the Earth's crust itself. In other words, these explosions also destroy the Earth's crust from within. Remember the earthquake in Turkey and Syria this year. After all, it occurred precisely in the zone where 90% of all deep focus earthquakes in the world were reported in 2021. Today, the number of deep focus earthquakes around the world is growing exponentially. And this means that our demise is approaching us exponentially. On November 24, 2023, 15 earthquakes occurred in the Mariana Trench area at the depths of 10 kilometers. Take a look at how the number of magnitude 4 earthquakes is increasing in the Mariana Trench region. And in this diagram, look at how over the years earthquakes in the Mariana Trench occur closer and closer to the Earth's crust, in the very zone where the Earth's crust is the thinnest and can be easily breached by hot magma. However, at lower depths, deep focus earthquakes do not occur, because below 300 kilometers in this zone, the mantle is almost entirely molten. And this is an indication that the energy is growing at a tremendous rate due to the external cosmic influence. Already now the mantle is melting faster every day, but this is just the beginning. At the end of 2024, we will enter a cycle where the external cosmic influence reaching the core will increase by orders of magnitude. And that means that the heating and melting of magma will increase tens of times more. Over time, this extremely hot magma will increasingly melt the mantle and rise closer to the surface. Currently, it is at a depth of 500–600 kilometers. But when the entire mantle melts and becomes uniformly hot, the deep focus earthquakes will stop, because there will be no more cold countercurrents. Everything will be fluid and hot, like melted cheese. As a result, the Earth's crust may be easily breached by magma. We are already seeing this trend under a vast territory of Western Siberia. This indicates that magma is approaching the Earth's crust very quickly over an extensive area. By the end of the cycle, our fate will be similar to that of Mars. Look at Mars. You can see huge lava flows on its surface when molten magma poured out without any resistance from the Mars's crust. Will we have time to stop this process on Earth and save humanity?